Welcome students. Let us proceed further to the next question. So the question goes like this. An inelastic string of length 240 mm, length of the string is given to us, is wound around a cylinder of 70 mm diameter, keeping the string always tight. Draw the curve generated by the end point of the string. So this particular sentence, draw the curve generated by end point of the string, reminds us that we have to draw an involute. And finally, we have to name the curve. So the curve name will be involute. Also, draw normal and tangent to a point which is 150 mm above the line. So in earlier questions, we used to draw normal and tangent to any point on the curve. Here it is mentioned that you have to draw normal and tangent to a point 150 mm above the line. So two things. One is the length of the string is given as 240 and normal and tangent should be drawn 150 mm above the line. Okay, starting with the construction. So first of all, as usual, we will be drawing a circle, radius 35 mm. Then we will divide the circle into 8 parts. So with this, we have divided the circle into 8 equal parts. Now we will draw a line equal to perimeter of a circle. So as the radius is 35, the circumference will come out to be as 219.8 mm. And now we need to divide this line into 8 equal parts. That is, as the number of parts we have divided the circle. So for that, I will take an angle approximately 30 degrees or so and will mark equidistance point. The distance is as per your choice. I am taking 2 centimeters. You can take 1 centimeter, 2.53, anything you want. I am taking 2 centimeters and will mark on this line 2, 4, then 6, then 8, then 10, 12, 14, and then finally 16. Now you need to join this last part of your measurement on this inclined line with the last part of your perimeter line. I repeat, you have to join the last part with the last part of the perimeter line. And then drawing the parallel lines from each point. After this part, we will give the naming to all the things like center and like points on the circle and the points which we got just now on the line. So starting with point 1 on this side of the circle. Now, to draw an involute of a circle, we need tangents to each and every point on the circle. So starting with point 1, and we know that tangents are always 90 degrees with the radius. So measuring 90 degrees from all the points. Starting from point 1, then moving to point 2, then point 3, point 4, point 5, point 6. I'm just marking the tangents to all the points. And finally, point 8, which will be same as this line. Now I will continue. So I will draw the tangents now, starting from point 1, then point 2. So till this step, as I mentioned in the previous question also, till this step, the process for drawing an involute of a circle will remain same. Now, after this, we need to check if there is any length of the thread given. So in the first question which I solved on involute of a circle, no length of the string was given. So we considered that the length of the string will be equal to perimeter of the circle. In second problem, the length of the string was given as 180. So we constructed the involute accordingly. And now in this particular question, we are given that the length of the string will be 240. So first what I need to do is mark 240 and I will name this point of 240 as point P. So this is point P for us now. Now we will measure the distance between any of the points, let us say 4 to 5 or 5 to 6. So this is coming out to be as 2.7. So what I will do is I will measure 2.7 from this point. From point 8, I will measure 2.7. So which is coming outside the point P. So no need to measure. If it is coming inside, we have to measure and name that as point 1 dash, or you can also name it as point 9. Now starting with the construction part, we have to measure the distance from point 1 to point P. And well, it should be measured from point 1 to point P, not to point 8, because the length of the string is more now. Then keeping the same radius, shifting the center to 1 on the circle, we need to make an arc on the tangent at 1. Measuring the distance from point 2 to point P, keeping the radius same and keeping the and center as point 2 on the circle, we have to make an arc on tangent at point 2. And then similarly, we will measure the distance from point 3 to point P, keeping the compass at point 3 on the circle, which will become the center now, and we will make an arc on projector of point 3. Proceeding in the similar way, now we will go for point 4, measuring the distance from point 4 to point P, then keeping it at point 4 and cutting an arc on tangent of point 4. And then point 5 to point P, keeping it on 5 and marking the radius on the projector or the tangent from point 5. Then again coming back to the measurement part, measuring from point 6 to point P, keeping the compass on point 6 and making an arc on the tangent of point 6. Then we will go for point 7, measuring distance from point 7 to point P, keeping the compass on point 7 now and making an arc on projector of point 7. And then finally measuring from point 8 to point P. So here what happens is my compass, the length which has to be measured is more than the least count of my compass. So in this case, what we need to do is just need to measure the distance between point 8 and point P, which is coming out to be as 2.4 or 2.5, 2.4. So what you need to do is come here at point 8 and on the tangent of 8, which is this one, measure 2.4. Now we will name the points which we have just marked. So starting with, let us say, point P1. So the curve should pass through all the points P1, P2, then P3, P4, then P5, P6, P7, P8, and maintaining the continuity of the curve, just join this curve on the circle. So this completes the involute of a circle whose length of the string was given as 240 mm. Now we need to give the dimensions to complete the part. And also in the question it was asked to name the curve. So I will name the curve as involute. Now we are required, after giving the dimensions part, this has completed the involute. Now we are also given that we need to draw normal and tangent to a point which is 150 mm above the line. So what you need to do is you need to take a scale, keep it this side, and measure 15 mm, that is 150. So let us say if I keep it here, 15 mm goes out of the curve. So I will slide my scale this side, and wherever this 15 mark touches the curve, this is the point on which I need to draw normal and tangent, which is 150 mm above the line. So I will mark this point. So this is the point on which I need to draw normal and tangent. So let me name this point as M. Then as per our regular procedure, we will join this point M with the center. And then divide this line CM into two equal parts by using the line bisector method. So I will keep the compass at point C, taking the distance more than half for this line. And then I will make a arc this side as well as this side. Similarly, with the same radius, we'll now keep it on point M and make an arc. Now joining these 2 points, The point at which it cuts the line CM is the exact center of this line. So let us say I will name this as point O. In the compass and measuring the distance from O to M, you can also take O to C because it is same. You have to draw a semicircle. So I'm drawing a semicircle here. Now, wherever this semicircle, I repeat, wherever this semicircle cuts the circle, that is this point, I will mark that point. So semicircle is cutting the circle at this particular point. Now, by means of a scale, you need to join this point with point M. And this line which we draw just now is nothing but the normal to point M. So this is, I will name it as normal and. And now we also know that normal and tangents are perpendicular to each other. So I will keep it at the point M and will just mark 90 degree with the normal somewhere here. And we'll join this line with point M, which is nothing but the tangent. So I will write this as tangent T and T. So this completes the problem in all respect. If you want, you can also give one more dimension, that is this one, wherein we have taken this point M at 150 mm above the ground. So you can measure this dimension also. You can show the dimension. So this completes the solution in all respects, wherein we have drawn an involute and we have also drawn a normal and tangent to the curve, which is at a distance of 150 mm from the ground or from the line. So I hope you have understood the entire concepts of construction for cycloid and involute. In the next class, we will take a problem on helix, which will complete the topic on engineering curves. Thank you.